Hello everyone. Today we are continuing proving shapes or parallelograms, quadrilateral parallelograms. Today we're going to talk about how to do it on a graph or a coordinate plane. So the couple ways we can do it is we can show the diagonals bisect each other. That requires two midpoints. Show both pairs of opposite sides are congruent. That's 4 distance formulas. Show both pairs of opposite sides are parallel. That's 4 slopes. Or show one pair of opposite sides are both congruent and parallel. So that's 2 distances and 2 slopes. So, reminder, what we're going to use to do this is our distance formula, our slope formula, and our midpoint. So, first thing I want you to do is I want you to pause on number 1, and I want you to plot these points. Okay, so you should have plotted these points. So then we're going to use the slope formula to show this is parallelogram. So what we want to do is we want to find the slope of all our sides. So we want to find the slope of AB, BC, CD, and AD. So reminder, our slope formula is y2 minus y1 over x2 minus x1. So first I'm going to find the slope of AB. You should indicate what side you're finding the slope of. So I'm going to do AB. So AB, I'm going to do 4 minus 1 over 3 minus 1. So that's 3 over 2. Then the side that should be the same is CD. So I want you to pause, and I want you to find the slope of CD. So hopefully you found the slope of CD. I did 1 minus negative 2 over 9 minus 7. You could have flipped that, but you should still get 3 equals 3 over 2. So then I'm going to say therefore, which is these 3 little dots, AB is parallel to CD, same slope. Okay, now I want you to pause, and I want you to find the slope of BC and the slope of AD. Okay, so I found the slope BC and the slope of AD. They're both negative 1/2. So I can say BC is parallel to AD. Same slope. And then I can say, therefore, ABCD is a parallelogram. Opposite sides parallel. So now we're going to do our next problem. So I want you to pause again, and I want you to try this one. So plot it, and then we're going to use the midpoint formula. So what do we want to find the midpoint of? We want to find the midpoints of the diagonals. So pause and find the midpoints of the diagonals. So I wanted to give you a little hint. So I plotted my points. My diagonals are QS and RT. And I want to find the midpoint. Midpoint formula is above if you forgot. Okay, so hopefully you found your midpoints. My midpoint at QS is 1/2 0, and my midpoint at RT is also 1/2 0. So what that tells me is that, so I'm going to say, therefore, QS and RT bisect each other because they share the same midpoint. And since they bisect each other, that means that QRST is a parallelogram. Diagonals bisect. Okay, one more problem for today. So let's work on this one together. So again, pause and plot these points. Okay, so now it wants me to show it's an isosceles triangle. So looking at this triangle, the two sides that look like they're the same to me are PA and AT. So if I want to show PA equals AT, I need to use the distance formula. So distance is square root x2 minus x1 squared plus y2 minus y1 squared. So I'm going to do that for PA. So PA equals the square root of -1 minus -4 squared plus -6 minus 5 squared. I do that on my calculator. And I got PA equals 11.40175.425. So now I'm going to do the same thing for AT. So it's -4 minus 5 squared plus 5 minus -2 squared. So again, I do that on my calculator. I got the exact same answer. So that means those two sides are equal, so it's an isosceles triangle. Is isosceles, two sides are equal. So now I want to find R, so that PART is a parallelogram. So I know that R needs to be in this area because I need to go in order. So PART. So to find R, what I'm going to do is I'm going to use the fact that my slopes have to be the same. So from P to T, you go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So I'm going to do that same thing from A. So I'm going to go up 4 and over 6. So R is going to be that point right there. And that's going to make this be a parallelogram. So R is 2, 9. And that's the end of our video today. If you have any questions, please let me know.